Okay, so in today's session we'll be discussing about the compare test. Okay, so compare test is basically okay the way to generate the signal. Okay, I discussed in one session that actually to generate the signal we have two process. Okay, or you can say to give the signal to the switches we have two steps. The first step is that you can give directly by the block, that is the pulse generator. Okay, so this pulse generator block will give me the direct pulses. Pulses means it is in the form of 1 and 0. 1 and 0, 1 and 0. Right. So if you take a pulse generator, okay, this is we can manipulate the values of the pulse generator. For example, amplitude, period, pulse width. That means if it is for 50%, for 50% switch is on, 50% switch is off. If it is 60%, 60% switch is on, 40% switch is off. Period I can give as per the frequency. Right. So this is the basic to create the pulses. Okay. For example, if I am using, let's say, 10 kilohertz switching frequency, so it is actually 10,000 hertz. 10,000 hertz. So I have to give here in terms of frequency. So I have to type here 1 by 10,000, right? Because period and frequency are opposite to each other, right? This is the way how we give the pulses. And similarly, let's say I'm giving a 70% of the pulse width. That means my pulse is on for 70%, off for 30%. On for 70%, off for 30%. Right. This is the case. So this is the pulse generator. Okay. To generate the pulses, 70% off, 30% off. 70% off, 30% off, 70% on, 30% off. This is the way how we generate the pulses. But this is a direct way to get. You can also generate the pulses with the help of the compare test. That means we have to go for the intersection. So what I am doing, I am intersecting one triangle wave with a constant. Okay, you see, we have a triangle wave. Triangle wave you can take by repeating sequence. If you double click, see I gave here the time values. So 0.02 is a time value. So if I write the reciprocal, it will be 1 upon 0.02. So it will be 100 by 2, 5. So it's a 50 hertz. 50 hertz is the frequency, right? Correct. So the maximum time period is here. By 2 we have to fill here. Okay, so that is a thing. So it is 0, 0 0.01, 0 0.02, 0 to 0. So we'll be getting a triangle wave. Correct. So I'm intersecting a triangle wave with the constant, and to change the constant I gave the slider again block. What is the meaning of slider again? You can check the values. You can manipulate the values while running. That is the meaning of slider again. So if you see the maximum y-axis, it is going 2. That means my slider again should not cross 2, as simple as. If it is crossing 2, I will be not getting the intersection. Because my triangle wave maximum limit is how much? It is 2, y-axis. It's a plot of time versus output. My maximum output is how much? 2. So to get the proper intersection, my constant should not go beyond 2. So to change that, I gave one slider again block. So the intersection will happen via the relational operator. Okay, and one to see the output properly, we use the mux operator. In mux operator, I gave one triangle wave, and I gave the constant output, that is the 1.16 as of now. Why? Because I changed the 1.16. Okay, so in this we have both the signal. That means if you want, you can write this is the triangle wave plus the constant, right? So actually it's the intersection. So the intersection part we can see here, right? So we can see here the intersection part here. And the resultant we can see here. Why? Because I connected after the relational operator, so you can see the resultant also here, right? See, this is the thing that we have to use. So triangle wave per constant intersection is here, resultant is here. We have a scope. So on the first part, upper plot, we can see the intersection. In the lower plot, we can see the pulses. So I'm running for infinite, or let's say run for 10 seconds, and just run it, and you can easily understand. Okay, the intersection part. Okay, so click on the scope, and you can see here. See, it's a very beautiful graph between the yellow color is the triangle wave, and this is my intersection with the 1.2, and you are getting a resultant pulse here. So at the point of intersection we are getting the wave. So at the point of intersection I am getting the wave. Okay, here on and off. At the point of intersection, the triangle is on the bottom side. Here it is the upside. This is also a way how to generate the pulses. Okay, and if you see, if you vary the let's say I'm running for infinite, while running I can vary the value of constant. So the value of constant will actually decide the how the wave will be generated. Let's open the scope, okay, and keep it here, okay, and you can see let's vary the slider again block. Okay, let's vary it to let's say 0.5. Okay, then you can see the scope, what is happening. See here. So now the intersection is at 0.5. So you can see it is getting increased. See, this is the way also to generate the pulses. Okay, so hope it is clear. So either you can generate the pulses directly by the pulse generator, or you can go for the intersection of the two waves. So generally we intersect the triangle with the constant. Triangle you can name as a repeating sequence with the constant, right? Okay, thank you.